Hi, Jasper.
Hi, Alf.
How are you?
I'm fine. I'm
Are
fine.
you moving forward with the evaporation business?
Yeah, I'm trying to get funding for the project through Blue Action Banners project, a European funding program.
Yes.
But I don't know the outcome yet, so I don't know whether or not I will get funding for that.
Well, everyone's looking for funding right enough.
It is a bit difficult. I can see that Southern Cross University is also working on evaporation cooling by fogging. Uh,
It's the way nature cools the planet.
yeah, exactly. So yeah. So this idea is to affect the hydrological cycle, to establish the hydrological cycle.
Indeed, of course.
Yeah, exactly.
I'm trying to set my.
Hi, Jesper.
Yeah,
Hello
hi, Clive.
there, Clive.
Hi,
Yeah.
Alf. Yeah, yeah, yeah. I was just thinking, what goes through my mind, Jesper, is what's the energy out? How much energy to put into your system compared to the amount of energy, um, extra energy, the difference in, well, it doesn't change the amount of energy at the top of the atmosphere, does it? Your system. This is what Robert Chris was saying.
No, exactly. But it converts sensible heat into latent heat and thereby reduce the temperature on the planet.
Right. So it makes it more bearable. So it
No,
makes
it's
it
not
more
just
bear.
that. It's not just that. It releases energy into space, high up in the
Well, yeah,
troposphere.
but not any quicker than it was getting released anyway, or is it getting released quicker than it was
It is
anyway?
quicker because it's if the hydrological cycle is working, I believe it is quicker.
Yeah, exactly.
Well, so
So
you can say does affect. Then in that case, you can say it does affect the
it,
change of energy imbalance at the top of the atmosphere.
yeah, exactly. It increases the heat rejection during the evening time, especially
Right.
where you have lower humidity.
So it moves the heat up higher up in altitude where it can escape more easily. Is
Exactly.
it right? Because you want a really non-technical way to just sort of say it very quickly that almost anyone can understand it. You know,
Yeah, I think the quickest way is to say that it convert sensible heat into latent heat
yeah. Most people have
and
no idea what that means, though. If you say it moves the heat higher up, which so it can escape more easily, most people can understand that. You know,
yeah,
most
exactly.
history
But
graduates,
But
right?
but
if
but
if you
but
have a ground temperature at 40 degrees centigrade and the air has a temperature of 40 degrees centigrade, then this adiabatic cooling creates a temperature difference. So the air can be reduced to
Yeah,
22 degrees centigrade
yeah,
and
fair enough.
thereby take out the heat of the ground and reject it into the to space.
Right. Okay. I mean, that's a
there's
science.
a huge amount of energy that's released when the water vapor condenses.
Yeah, exactly.
Right.
Exactly.
Okay. Anyway, it's time to start. We're already chatting at the beginning. Good afternoon, Brew.
Hi, I've lost you all at the moment. This was on screen come up front. There, you're all back.
Okay.
Greetings.
Good. Greetings. Right. And who else have we got? I think we just got a small group today. Oh no, we haven't got four more people. Mike
Has
Williamson.
Mike Williamson been introduced?
I
Did I miss that?
I think so. I think Mike, you've been along a little, quite a few times. Yeah. Do you want
Yeah,
to
yeah,
say
I
something?
have been. I just in the background.
Yeah, but I think you did introduce yourself a while ago when you
Yep,
first started coming along. Yeah. And you're an oceanographer, is that right?
marine geophysicist. Yeah.
Marine geophysicist, right? Yeah. Yeah. So, your style is up to you. You can feel free to pitch in. You're always welcome to pitch in. I like, as might be able to tell, a variety of voices. Um, so, I don't like to, well, I do like hearing from anybody, but when it's the same people all the time, it's always good to hear a different opinion. Um, right, and welcome John and Chris Vivian and Sev and Greg, of course, and I'm not trying to put anybody off from speaking. I just like to see more competition for speak. Anyway, so and then my job then becomes uh, more important to move on to the next subject, of course. Right. So, and hi, John.
Hi, Clive.
Thank you for your
Hi,
lovely
John.
song
That's a
that you
pleasure.
produced for me. Yeah, yeah, that
It's a
came.
bit of fun.
Right,
Yes.
I bet it was.
Yes.
I like
Thank you,
it.
John. The great composer.
Well, no, AI takes a lot of credit for it.
It
Still,
does
not
it.
all me. It's a lovely thought, and thank you very much.
Yeah, well, we've got to recognize each other, don't we? It's all part of it.
Yeah, that's a lovely way to do that, John.
Well,
Are
yeah.
you thinking of kind of promoting it? So,
Well, I thought I'd put a number of them onto something like X or YouTube, just so that as a collection, and under the banner "We Are the Dreamers." So
lovely. Yeah,
it's just
that's
so
fantastic. Yeah, go on.
yeah. Well, look, I don't know how many people will see it, but there's a subtle motive behind it to get the message out as well,
Of course, yeah.
as promote as well as recognise the work of all of us. So yeah, there's multiple reasons for doing it,
Yeah,
and
yeah,
hopefully people learn something from it, from the work that's been done.
right. I mean, you might be able to reach the parts, we just don't reach. Like youngsters
That's it.
are
Yeah.
all, depressed and crying in their beer, and seriously.
Yeah.
And so it's and you're thinking of writing a book as well?
Well, that's in the background. I've done most of it, but to get a publisher it is a challenge,
Yeah, right. Yeah.
considering
Thing
the
is,
market.
it's really good for people to be aware that
Yeah.
there's people writing songs, and people trying to write books. We know we've got very good writers. We see them all the time. Um, and and so collaboration is no one can do these things on their own. So
Yeah.
collaboration, yeah. You might find that people like a certain tune, or one song does better than all the others.
Yeah. Yeah.
Irrespective of the particular name in use. Nobody knows who we are anyway, or that people listening to
Well,
songs wouldn't anyway. Um, and yeah, so it
yeah.
can all be helpful.
Yeah. There's one I produced recently, which is really out there. It's really hyped up, actually, but
Mhm.
it's deliberately designed for young people to take action. It's called Thermostat.
Right.
About them taking control, and you guys haven't done it, so we're going to do it, sort of story, and that is right out there. But they're the
Excellent.
people that have to listen. It's the next generation. It's not us. It's the next generation need to grab this thing.
Yeah, absolutely.
So they've got to relate to it, and not just think there's a lot of old guys with good ideas. So I mean, being quite blunt about it. That's what's happening. We've got to get to the young ones and give them hope with new ideas.
Yeah, yeah. So this one that's taken off that you said, could you give us put a link in the chat on that? Is it ready for us to?
John's breaking up a bit.
Beg your pardon? I'm breaking up.
Which one's taken off?
John's words are breaking up
Are they?
on my
Sorry.
screen.
Yes, it said my internet was playing up a bit.
Yeah.
Sorry
So
about that.
just saying that one, you said one of them has taken off. One of your songs is doing well.
Yes.
Just
I don't know
can
whether
you
it's
put a
taken
link
off.
in for it, John? Put a link in the
I'm
chat
not sure
to
whether
us.
it's taken off, but I've certainly put it out there just yesterday, so I can put it in the link. Yeah, and it'd be interesting. I mean, it takes a day or so to see the reaction. It'd
Yeah.
be interesting to see the numbers.
Yeah.
But I'm getting between about 60 and 150 people listening every day. So I guess that's building up as a number.
Yeah.
I mean, not getting the thousands or anything, but it's a solid number every day that are listening. And I guess they're searching and they're picking up a particular theme, so they're listening on that basis. And the heading probably helps as well. If you've got a catchy sort of heading, and that sounds interesting, and it's just a 5-second grab, like most things these days.
Yeah.
But
Where have you
this is
posted
an
it,
easy
John?
way to do that because they're very short. They're less than 3 minutes, these things. So it's a very short sort of thing.
Yeah. Bruce?
Where did you post it,
by the way?
John?
Let Bruce speak, please.
Where did you post it, John?
On this Musicful app.
On the Musicful,
It's
okay.
AI Musicful app. Yeah.
Yeah, just there's a public content there, and you can write a comment next to it as well, which I've done on a few of them too. So,
Yeah. Who else is
but
speaking?
I was just going to say that you might want to think of using something like TikTok to promote it, because that's where young people are concentrated.
right,
Is much more on TikTok than anywhere else.
they're probably right, Chris. I'm not on that, but I'm maybe if there's no age limit, I'll see if I can join.
It's quite easy to get onto, John, I found.
Yeah.
And
Okay.
then didn't use. Right, let's get going. I think let's get going with this. So where are we? Share. No, I've done an agenda today. Where is it? Right, am I looking? Can you see? You should be able to see something saying agenda on it. Can you?
Yes.
Yep. No.
Right.
Mhm.
Okay. So for everyone. I was thinking about you today, Gene, as well. You had a lot to say when you first joined us. You've obviously worked very hard on climate models, including your own climate model, and I don't remember much about it. So I think I'd love to hear a bit more from you on I don't know, your climate model, just anything, because I feel like I cut, probably didn't give you enough time to explain your climate model, Gene.
Well,
I'm just feeling a bit guilty about it. That's all it is, really. So I think we've
I'm
got to be
willing to talk. If you want to allocate me some time, I can
well.
spend 5 minutes. I can spend 15 or
Yeah.
whatever
Well,
interests you. It's
yeah. Okay. So let's put my. I'll have my item. What would be the most important thing that anybody should say? Well, from your point of view, what's the most important thing um, to be said as from your point of view?
um, we need to get rid of the carbon legacy emissions, and while we do that, we need to cool our Earth off.
Yeah. Okay. We need to
I
cool
mean,
the Earth.
that's the policy actions we need to take.
Yeah.
If we don't, we lose everything that's dear to us,
Yeah.
including most of the human
But
population.
Gene, I mean, you're focused on the albedo, the recognition of the crucial nature of the albedo, understanding the albedo evolution, right? I mean, that it's misunderstood, right? In your perspective, I'm just trying to,
Um,
you know.
I
Yeah.
think that albedo change has been underestimated, and developments in just the last several years have really underscored that. I think that the albedo change from cloud loss has jumped out, and I regard that as huge.
Right. So this is what I've been looking for a very short title to put on the agenda uh, for like a 10 or 15 minutes. So, I mean, we all know we in this group, we know the very first thing, cut emissions
Yeah,
and cool the
and I
planet.
would
But we
like to,
hear more your sort of detail. Albedo loss more than thought.
and
I've
recently I've learned things about climate sensitivity, and there are several of them. I've been focused on the long run,
right.
and I don't know if that's worth sharing with you.
Yeah, I'd be interested in that. Let me just very from my point of view, I've as you might have seen, I have produced these interactive charts online, so you can click a button and it shows you the effective rate forcing of everything minus CO2 or just separate methane or whatever, and the cooling aspect as well from aerosol interaction. And what I want to do, what I'd love to be able to do, and failed so far, is put a little extra button on it to show not just the Forster, the IPCC as reported by the IPCC aerosol cooling, anthropogenic aerosol cooling, but also other people's view of that. Because Jim Hans is saying it's been underestimated, maybe double, maybe minus 2 watts. So do you have that data?
Well, I have an estimate. It's not yet well grounded, but it's probably more than 1 watt per square meter, might be 1.4.
Right. Okay. But
That's a lot.
yeah, yeah. So here's the time series of would you have that? You wouldn't have that going back necessarily because there are some papers and Jim Hansen plots it out as well. He plots it out going to over time and how it's off for a long time. It's been much more than the IPCC. You know, much more cooling than the IPCC were saying.
No, Hansen has a much deeper data set than
Right.
I do. I'm
Right. And he quotes,
repackaging stuff I find from him and Cellutis and some other people.
right.
Clive, can I just
Yeah.
say on that aspect that
Yeah.
you have the interactive chart and others have are you imagining then that, you know, in your interactive tool, you can add or remove from the plot different components of say of the GHG or the climate influencing
Yeah.
components.
Yeah.
But in that way, you can bring in you could bring in different models. So
Yeah.
you could have, yeah, I mean I think that would be a very valuable thing to have people. So you show here's Jim Hansen's take, and then you have, you know, the canonical one. And you have, you know, here's Michael Mann. You know, I mean, you have the charts for these guys rather than they just say, don't worry about it or worry about it. You say, this is what they're, and, you know, I think having them, be able to graphically show the difference between, or at least the spread between the models, it would be a very valuable thing. That's just my reaction to what you just said.
Well, great. Thank you. Yeah. And so I looked at one of the, Hansen talks about a paper from Bauer, B-U-A-R or something like that, B-A-U-E-R or whatever.
Oh, yeah, Wolfgang. Yeah,
Is it Wolfgang? I thought it was Suzanne, but anyway, whoever it was.
Maybe two people.
Maybe. And then it said, you know, here's where you can get the data, 4 different links for 4 different countries. And only one of them actually came up with some, I couldn't get it back, bottom line. I couldn't get the data. Or didn't know how to in these sort of, you know, very specialist websites. So if you know how to get that or can get it, then yeah, I'd be extremely interested in that because yeah, I'd love to be able to add that into this thing. I don't really think anyone cares about last year's version or the data as was in 2024. Hardly changes, you know. They update it a bit each year. You see,
I'd love it if you could put the URL for that in the chat.
Yeah. There it is. Yeah. Where's the chat? Here somewhere. I'm desperately trying not to. There we go. Come on, chat. Right. So this is I'll say interactive. I'd say ERF charts. Does that mean something? Or effective relative forcing charts. It's right there. That's a Microsoft. I mean, that's Microsoft's sort of website, if you like. It's a huge thing that anybody can put their customer. This would normally be, you know, milk bottles or whatever, company information. Right. Okay. Yeah. So let's hear from you. I'd love to hear a bit more from you, Gene, about this stuff. These 2 things: Albedo lost more than thought, and cooling. Yeah. So aerosol, just say aerosol.
Sensitivity was the other topic.
Yeah. ECS higher than thought. Yeah. Okay. Right. That's good. AER. All right. Well, let's try this. Yeah. So, right. Chris, Vivian, I think you've had your hand up for a very long time. Please.
I'm going to say, I don't know how many of you saw, there was a Anton Alferness has done a Scrubbing the Skies episode with Wilbert, which is called, so let me get it right, How to Fund Ocean Fertilization Research. That's basically it. And it's like an hour-long episode with about a half an hour or 20-minute presentation followed by questions and so on. So I can put the link in the chat. I'm not suggesting we need to discuss it now, but I think it's interesting as it's basically designed to get around the London Convention's thing about you can't get or you shouldn't get any economic benefit from research. So he's come up with a scheme to do that, which I think is interesting. Whether it would work exactly or not, I'm not sure, but it's certainly, I think, a possibility. And I'll put the chat into the link into the chat, sorry, in a minute.
Right. You shouldn't benefit from research. I mean, that is just
Well, the
criminal.
economic benefit, i.e., if you shouldn't get like carbon credits from doing research, that if you're sinking carbon, people can invest in companies, no problem, but you
Right.
can't benefit directly from the research.
Okay.
Different for commercial, of course. That doesn't apply to commercial things, but for research, that's what it applies
You
to.
shouldn't benefit financially from research, is that?
Well, you shouldn't benefit from the carbon or carbon credits or anything like that.
Okay, you can't get carbon credits for research. Okay. Okay. No carbon credits for research. Okay. Let's put it like that then.
I'll find the link in a minute and stick
Right.
it in the chat.
Yeah. Carbon credits. Right. Let's take that out. Sorry. Right. Okay. Thanks, Chris. Okay. Anyone else?
Somebody.
Well, it would be interesting to no, that's more of a question than an answer, but just to have a discussion about the impact of cosmic dust on cloud formation and rainfall. I believe it's fairly small, but there is a component of cooling that comes from normal cosmic dust as opposed to terrestrial dust.
Yeah, I
I
think
remember looking at some data on the impact of cosmic rays on clouds and Earth's temperature.
Right.
Not the same as cosmic dust, but was interesting.
Yeah.
Hmm.
Yeah.
Okay.
Anyone else got anything to say about it? Because I think we might be able to dispatch that.
The thing which I've come across, I can't remember if I mentioned it before, there's an idea for generating sea ice. It's called wood ice seed or sea ice generation. And there was a paper on Research Square. I can't remember whether I mentioned it before. I don't think I did.
No, I don't think
so. It might be just of interest. I can again post that in the chat. It's came out actually last year, but it still hasn't appeared as a final paper as yet.
Something like that. Wood chips or something, is that?
No, I've just put it in the chat. Wood ice seed or sea ice generation.
Oh, got it. No, oh, sorry, I'm with you now. Wood ice seed.
Wood as in the material, not wood as in could.
Right. So like, no, not like, I said it is wood.
Wood,
It is wood,
yes.
the material. Right. Okay.
Wood, yeah.
Wood ice seed.
Seed.
Right. Right.
For sea ice.
Right.
I want to know what wood ice is.
Generation.
Oh, thank you. Right.
The link's in the chat there.
Okay. Well, okay. Are you going to say something about it, or is it just for a link?
I can say a little bit about it. It's say a little bit about what it's about.
Okay. So let's have that as a small item then.
So that's ice from trees, wood?
No. You put the wood into the sea in a way that helps generate sea ice in the Arctic.
Okay, got it. I understand what
sawdust.
We're talking of Arctic sea ice. It's not quite dust. I don't think
something like cloud seeding, perhaps, in the atmosphere.
Not quite. It involves removing some of the lignin from wood, for example. Anyway, well, I'll talk about it later.
Yeah, I think if only to leave people not completely confused, Chris. It's not your fault. It's just I think the heading itself is probably a bit of a play on words. Anyway, right. I've been reading stuff from Tom Harris. Been trying to persuade him to come and join us and talk to us. I don't know if he's here.
I see his posts a lot.
Yeah, and I find him really very good. It's
amen.
Yeah. That's it. He's good and worth reading. So he's not here right now, at least. Anyway, so his are, yeah, so let's mention this, Clive. Yeah, I'll put this at the end. So if there's time. There we go. Right, maybe that's just about. I think the main thing here is maybe you could speak for more than 15 minutes, Gene. I think we might like to hear from you for more than 15 minutes and have a good old discussion. Have you got sorry to spring this on you, Gene. Um uh, uh, do you have material reasonably at hand to bring up graphs and so on?
Yes, some I can refer to, and some of it I'll just talk. Wanted to do a couple of screen shares. Some of you have seen this before.
Yeah.
Send a request to turn on screen sharing.
Yeah, sorry. Yeah, I have to do that. Yeah. Where are we? God, they change it all the time. They've taken away the host tools. Right. So I think I have to take this off. Do it like
Okay.
that. And share all participants. Yep. How many participants share at the same time? Oh, let's have one at a time. Yep. Okay, that's it.
Okay.
Try again, please.
Okay. Let's see if that does it. Okay.
Right, so we're on to you now then, Gene. I think that's going to be our main. Unless there was just anything else for anybody from anyone else. All right, so please, yeah, go ahead then, Gene.
So I think people, HPAC, who include some of you, saw this slide, which I got from Jim Hansen's press conference after his beginning of 2025 paper on global warming is accelerated. I've since seen it from other people and other versions add a few months after this. But the basic thing, I looked at this and said, well, albedo and I've also had my brother suggest that I might look at different albedo sets, and one that did Earthshine that I looked at a few months ago springs to mind, so I need to cross-check that. I perceive the authors said they got only about half as much, but I looked at their numbers and they looked like just about as much, so I need to look at that again. So anyway, this loss of 0.64% of Earth's reflectivity. Basically, you apply that incoming sunlight, divide by the area of the Earth, and get 2.19 watts per square meter of radiative forcing. When you divide it by the temperature rise during the time, that's 3.5 watts per square meter per degree Celsius. And I thought, well, how does that compare with that from greenhouse gases? So I found this data at the end of 2024 from NOAA.
Sorry, Gene, just a moment. You said that that change of albedo gives a change of radiative forcing of 2 watts per meter squared.
A little bit more, yeah.
Are other scientists saying that? I mean, that is huge.
That is huge.
Are other scientists saying the same thing?
I don't recall other scientists mentioning that.
I mean, that is
it is huge.
Because that change of 29 down to, sorry, 29.5, that graph is showing what,
29.36
In the
or
text, Clive,
so.
you can read it.
Oh yeah, turning to 28. So that's not a change of that's a change of percentage of the cloud that's there.
That's the percentage of the incoming sunlight has reflected has decreased.
Right, but is that of the clouds that are there, they've reduced by that many percentages, or the overall albedo of
Clouds are
cloud
some fraction of that.
Yeah.
And they are less than the full amount. Some of it is ice loss, snow loss, and probably over that time frame, aerosols loss.
Right. I mean, okay. So this is Earth's albedo in percent. So this is okay. Sorry, I'll just go quiet again. Sorry, I just had a sort of visceral reaction of a 2 watts per meter squared radiative forcing. I mean, that
Yeah,
is half
that's
of all green. I mean, a doubling of CO2 is only 3.7.
yeah,
Yeah,
it's very
sorry.
big.
Yeah,
And I reached that idea certainly 11 years ago when I did a regression of CO2 against temperature over the several recent ice ages, and it showed a long run climate equilibrium sensitivity of somewhere between 8 and 9 degrees Celsius per doubling. And I've since found just a few days ago that there's a literature which is well populated in that range. Uh, People are often talking about much shorter run climate sensitivity, but that's the long run, and it's very solid for any time you look seriously at the paleoclimate record, as a number of scientists have done.
right.
Uh,
Sorry, just a sec, Gene. I've got a message saying that you want multiple presenters to share, that you're requesting. Have you got a way of showing multiple slides? Is that what you're trying to do, or is that just a mistake?
I'm just trying to share with you things
Okay,
that I think that I found out.
right. So one screen at a time.
Yeah,
Right.
do
So
I have more than one?
it says you're asking to have more than one screen shared at a time. So I'm just going to
Oh,
get rid of that.
no, I
Yeah.
don't want that.
Yeah. Yeah. Right. Sorry. So while I was just agonizing over that, so you just said, sorry, everyone, climate sensitivity is what?
For the long run,
Yeah.
which allows thousands and tens of thousands of years, is somewhere between 8 and 9 degrees
Yeah.
Celsius for
Yeah.
doubled CO2. And there's a
Yeah.
lot of agreement about that I've
Yeah.
just learned about quite recently, thanks to Tom Harris and Dean Vorang's work that I heard about from Tom Harris.
Yeah.
Um, and I wondered, how does that compare with the forcing from greenhouse gases over the same time period? And this slide says, basically we got 0.95 watts per square meter from greenhouse gases added over the same time period, 2000 to 2025. And the albedo loss effect is more than twice as much as the effect from greenhouse gases over the same time period. Not only that, it's um, almost half as much as the effect of greenhouse gases we've added since we started adding them. I don't say that on
Yeah.
this slide, but
No.
that's about 3.5. Um,
Right.
and
Uh-huh. Yeah.
so I'm wondering, I think clouds, I remember reading something from a scientist named Kate Marvel roughly a year ago that virtually all the differences among the climate models in the temperatures they get and their estimates of climate sensitivities. And I think I have another slide maybe in here that shows 36 of those, is in their treatment of clouds. And clouds is a big thing. I wound up via Tom Harris again on Dean Vorag's most recent blog, and it's similar to Tom Harris, also very high quality, that there are formulas from which you can calculate these various things. And the role of clouds is the most poorly known of the various factors. Some of them, there's a Planck something that seems to be very precisely known and also pretty precisely known for water vapor feedback in the atmosphere. And when I put in the numbers for what I thought was good for clouds using Vorang's formula, which I guess are standard formulas, but that's where I saw them, that the ECS, which is the fairly short run Earth climate sensitivity, which might play out over a century, for example, I got 7, which is almost 9,
What,
which you get from the long run. And I wondered, well, what's going on? The
seven
differences
cent,
between
7 degrees centigrade rise for long.
instead of 3, which is Charney report's number for the same thing.
Hmm.
And that's almost entirely due to a different perception of the how strong the role of clouds has been as best I can determine in what I have seen. I'm not an expert in clouds at any stretch of the imagination, but I've learned a little bit at least. And I suspect I overestimated, but I look at what's the difference between the short run ECS climate sensitivity, which I think the IPCC said is most recently 2.5 to 4, and Hansen says 4.5, although I think he really said 4.8. And there are quite a few other modelers out there, probably a quarter the CMIP6 climate sensitivities are above 4.8. I think about what's in the long run that's not in the short run. Well, you've got your ice sheet adjustments, you've got lots of vegetation adjustments, probably not much in the way of tectonic plates. And I forget the other adjustments, but
Well,
I'm thinking,
it's CO2 coming out the soil and methane coming out of the frozen methane hydrates, all those sort of things, isn't it?
probably not, because that changes your CO2 concentrations. We're trying to hold CO2 concentrations fixed, and other things are changing. I thought, well, how much watts per square meter is the forcing from the ice we have on the planet? And Antarctica is similar to southern sea ice. Greenland is less than northern sea ice in terms of the area covered and also allowing for the sun angle. And vegetation changes mostly are going to be losing forests as the soils dry out in a hotter world. The forest will move away from the equator tendency and toward the poles, but there's a lot less area at the poles than there is in the equator. So by and large, you'll be turning forests to grasslands, at least on land. And grasslands have a higher albedo, not a lower albedo. And I just have this gut feeling acquired over the past week as I think about it more and become more acquainted with Vorang's work and Harris's, that the difference between the ECS and I think it's ECS and ESS, which is the most long run you get from paleoclimate records, is not going to be that great, because losing your land ice is not going to produce that much effect, probably
Yeah,
less than losing sea ice.
right.
And the vegetation effect is going to go in the other direction. It has the opposite sign.
Right. But this thing about you're saying that it's a highly theoretical to say that the ECS is still only a doubling of CO2. So it's a totally different scenario. So it means that you end up with a doubling of CO2 after thousands of years, which means that you stop emitting CO2. Right now, we'd be long ago, would be net zero, wouldn't we? So are you sure that is the definition of ESS? Because I'd always assumed that it was you double CO2 and then what happens? More CO2 gets emitted by the Earth systems.
It's what happens after many thousands of years. That's ESS.
Right, but ESS after many thousands of years, because the world warms up, that then induces more CO2 emissions from soils and from organic breakdown and methane from the frozen hydrates, which then becomes CO2. So you end up with much more than a doubling of
Absolutely.
CO2. Right,
Absolutely. And quite possibly double the CO2 levels we have now, even if we stop emitting now, because the sink's turning to sources. And that's temperature dependent. And as your
right,
temperature goes up, you're outgassing the CO2 from the oceans, the forests, soils,
right.
and
But so that's isn't that the reason why ECS is such a higher it's so as you say it's not really a change in ice sheets, it's not really a change of land use. If anything is more a higher albedo. It must be because these sort of sinks become sources, and so you end up with quite a lot more. You emit a little bit of CO2, but then the
oh,
system
you may
adds a whole
wind
lot
up
more.
with 1120 instead of 560. You may have a quadrupling as a result of sinks turning into sources. And
Yeah,
I've more or less run that case 11 years ago with a little spreadsheet model.
right,
Um, but the ECS has the CO2 level fixed, and it's just saying how much effect is there in the out years, and that's For me, it's much more dominated by albedo, and the albedo change, aerosols are important, but clouds seem to be the biggest contributor. And of course,
Okay.
aerosols and clouds overlap each other because of the cloud condensation nuclei effect.
Right.
But I suspect that this short run thing that Charney has at 3 is really dominated by cloud feedbacks. And that is saying, and we're seeing that, I think, the estimates of the Charney ECS, or the ECS starting with Charney, as I saw it in Dean Vorang's website and worked through that a couple of days ago, was that the ECS estimate using basically our CO2 levels and our temperatures has been increasing as we come forward in time from 2.73 watts per square meter. Most recent decade, that's up about 3.4. And I think what we're seeing is the unfolding of cloud albedo effect, which is not instantaneous, but kind of builds on itself.
Yeah. Okay. So
Declines.
I'd like to say something about that, which is the loss of which Tom Harris pointed out as well. Loss of but not because someone else has got their hand, but just as a sort of like marker. Loss of stratification, loss of uh, growth in the ocean, phytoplankton, loss of DMS. I'm finding the chat bots are saying, the chat models are saying this now as well, the
Yeah,
LLMs.
I regard that as the primary sources of faster acceleration. I mean,
Okay. Fine. So let's have Robert Chris, because he's had his hand up for quite some time. He might want to go back. Let's, Robert, please.
Yeah, I'm interested in Gene in these numbers because I get very confused about this split between the the warming effect from the greenhouse gases and albedo, because when you talk about ECS, which is specifically a carbon dioxide statistic, and it's essentially the equilibrium warming on doubling of atmospheric concentration of CO2. As Hansen pointed out in his pipeline paper, about 30% of that warming from carbon dioxide is the direct warming from the greenhouse gas itself. And about 70% is feedback, short-term feedback, not the ice sheet stuff that's in the ESS, but the short-term stuff, particularly to do with clouds.
Yes.
And and of that 70%, a big chunk will be albedo. It's not all albedo, but a big chunk of it will be albedo. So what I'm concerned about when we have this conversation here is the extent to which there's potential for double counting, because when you're measuring the albedo in the way you have, don't you need to make sure that that you're not double counting the albedo effect that's already included in the ECS statistic?
That may be. I remember reading Dean Vorang on that a couple of days ago and looking at Hansen's case and saying Hansen thinks we have underestimated the albedo effect from clouds and underestimated the aerosol effect.
Correct. Yeah.
And yeah, and therefore that he is arguing that we have underestimated the ECS, Earth climate sensitivity, which is somewhat short term. Vorang puts it out at like 100 years, which is much shorter term than 100,000 years, which is what I've started out with. And I'm just blown away by the albedo effect. Let's see. Yeah. You may remember seeing this graph, which I took George Seleutis' work. I first heard of him when Hansen had his most recent press conference after global warming is accelerated. And this shows I think, a very large albedo effect for ocean clouds. And I think there's some there's another caveat that when you have less area, you may have more higher, more opaque clouds. So it's not a one-to-one albedo loss with this. And I think that's getting me to the area where I'm starting to make sense of the big picture, but I'm not, have not checked it and formulated enough. But yeah, I think I don't want to double count. And yeah, but I'm not sure that I am. I think my impression at this point, at this stage of my investigation, is that the IPCC has been using a much lower coefficient for cloud forcing, akin to what Mark Zelenka was using 2017, which I used in my spreadsheet model. And what it's looking like is, roughly three times that much. He had 0.47 watts per square meter per Kelvin. And based off that, primarily off this, which is 2.19 watts per square meter. And I'm well, the calculations I've done, they're still kind of free flowing, or in the vicinity of 1.4 watts per square meter due to clouds. And I don't know enough yet to pin it down better that it might be a bit less than that, but I don't think it's a lot less than 1.4.
0.4. Yeah.
Yeah. I mean, Hansen put it at 1.0. And he put Aerosols at 0.5 and cryosphere about 0.2. And, the aerosols is big, and certainly I did my first analysis on that about 11 years ago. And it was a big thing. But
Yes.
I don't know that I would, I don't have a position yet where I can say with how close I come to Hansen's, but I think we're in the same ballpark at least in terms of aerosol forcing.
Okay. Are you happy to take a couple more questions? More people have got their hands up, Gene.
Yeah, I'll do what I can.
Okay, so Brew then, please. Thank you.
Sure. Gene, I'm interested how they're measuring this overall albedo. Is this the reflectivity off the moon?
No, this is from CERES satellites. So it's go back here. That would be the orange lines here, but extended another 10 years off to the right.
Right. And
But
have you?
I've not done anything with Earthshine.
Okay, because the Earthshine one seemed to be an interesting overview on this to me. I was just wondering how it matched, but
Well, I looked at the study briefly a few months ago, and the abstract said you got about half as much as what the satellites got. And I looked at the study and looked at the numbers were there, and the numbers seemed to be identical. Well, not identical, but pretty close to each other. And I haven't gone back to read it. I'm not sure I'm expert enough to really explain what I thought I learned, or
yeah.
I was like, well, I don't really know. That was probably the
Okay. Yeah, my only other comment on this one would be is in terms of the Earth system sensitivity, is the what I describe as the hyper exponential problem, where you have a number of exponential feedbacks which are all interfering with each other to drive it hyper exponential, which is where you get the very high figures for Earth system sensitivity.
Yeah. I remember. Let me go much farther on in this same paper. And let me show you this. This is from 11 years ago, and I think it overlaps with what somebody else was saying. So I did these scenarios and spreadsheet model and have a few cases, not all of which are still on here. But there's a cold turkey, stop fossil fuel emissions immediately. That's the magenta. Black is peak in 2035, and the orange, which you can kind of see,
Oh, right.
is end fossil fuels by 2050. And then there's carbon dioxide removal, about half of all our CO2 emissions to date. And I, just by gut feeling, a little bit of reading the literature, mostly about permafrost, said, well, as you warm things up, you're going to rev up carbon sinks becoming carbon sources.
Yes.
And except for permafrost, I don't have a lot of confidence in the numbers I put here, but I think it's going to be large. And because the CO2 is increasing a lot. I mean, it's what,
Yeah,
up 2.5 times in a couple of cases.
I'm not seeing anything about CH4 in your data here, of course, which is
Yeah, I think what I did is make the assumption, which is a very rough assumption, very rough, that CO2 and CH4 would rise at the same percentages as each other. And historically, methane percentage-wise much more steeply in the 19th century, which says to me coal mines, and CO2 somewhat more in the 20th century. CH4 almost stopped decreasing in the 20-aughts, maybe as late as 2012, and has since resumed a significant climb. But I don't pay as close attention to it, so for whatever that's worth.
Okay, thank you. And Robert Tulip, then, please.
Hi.
Hi.
Sorry, I only came in at 6:30, so I missed at the start, but I wanted to respond to Robert Chris's comments about double counting, and it's something that I've been trying to get my head around, and it's not easy by any means. So I've put a comment in the chat, which is my understanding of the double counting issue, and that is that the forcing is about 0.04 watts per meter per year from new emissions from the greenhouse effect, and that's an IPCC number. And then if you want to understand albedo, then the CERES data shows that the decline of reflectivity over the last 20 years is 2.1 watts, which gives about 0.2 watts per year, but that's accelerating. It's been doubling each decade, the rate of increase. And so that means that the albedo warming is roughly 5 times the greenhouse warming. But I don't have the expertise to say is that an accurate statement, and I haven't really been able to find a definitive scientific comparison. Like we have the Hansen's really important comment that albedo loss over the years from 2015 to 2023, roughly 8 years, was equivalent to 40 years of the greenhouse effect. Again, that supports that roughly 5 times that albedo is causing 5 times as much warming.
I thought it was 40 years of CO2 emissions, Robert.
Yeah, so Hansen, he said that the albedo loss since 2015, this was in a paper published in 2024, that was equivalent to an increase of greenhouse of CO2 concentration by 110 parts per million, which is 40 years of CO2. So there is this information in Hansen's work, and then you've like Loeb. He points out that as the albedo declines, the long wave radiation also increases. So the arithmetic of all this is very complicated, and I have not seen it explained in a simple and clear way for the general public.
Well, thinking about the 0.2 watts per square meter from albedo versus 0.04 from greenhouse gases, the information I've seen on this slide, which I got via Hansen, and this one, I'm looking at about 0.09 for albedo and 0.04 for greenhouse gases. So I don't have an explanation for the 0.2 watts per square meter per year.
But your y-axis there is the ratio. It's not the watts.
Yes, to get watts per square meter, I have to multiply by the
so basically it's
average
fallen
insolation, the sun insolation.
Yeah. So it's fallen by 2.19 watts, as you point out, which over 20 years, 25
According
years.
to satellites, anyway. Yeah.
Which gives about 0.2 per year.
About with 25 years, that's about 0.09.
Yeah. No.
No, I don't get
Well,
I
wait a
don't
minute.
get 0.2 watts per square meter. I don't get the number that was in the chart.
Well,
I think I've seen that before, but it's not.
Sorry, you're right. You're absolutely right. That 0.9.
0.09. Yeah.
0.09. Yeah.
So that's what I get. I don't know the source of 0.2. I
No,
think
I
I've
think
seen
that's
it
wrong.
before, but it's not something I'd be willing to hang much on unless I see a lot more than I've seen. And maybe I need to be educated, but 0.09 is huge. And
Sure.
0.2
Okay.
is even huger.
So that gives roughly double, not 5 times. Yeah.
Yeah, somewhat more than double, a little more than double. Yeah. So that's where I'm at in my state of knowledge. And
the other thing is that
0.09 is huge. It really is.
Yeah. The other thing is that the CERES data shows a much steeper increase of the rate of decline than this graph from Hansen.
Well, I've seen other versions of the graph that have a lot of the same data, but the horizontal axis is the same measurement as the vertical axis, and that makes that look steeper. And I think I forget who I saw that from, somebody in HPAC or possibly NOAC. And you can change your vertical axis and make it look steeper. And there may have been a bit steepness after the end of this record in early 2025. It's now middle of 2026.
What I mean by steepness is that it's now steeper since like 2023. So from 2015, the slope of the graph of the line increases downwards and then increases again. So it's been the loss of albedo has been accelerating.
Yeah, I see a turning point kind of at 2013 here.
Yeah.
And somebody was certainly making that a point. He had a 3 a 3-segment graph to approximate this, but I can't remember the name of the person who did that.
Well, I made a graph like that from Elliot Jacobson's use of the monthly CERES data.
Yeah. And what I see is with what's happening with the thermal stratification growing much stronger in the world ocean, is I see two kinds of acceleration. There's a cloud acceleration, cloud-based, which increases the heat energy absorbed by the Earth, which results in increased long-wave radiation going out. And I see that the heat absorbed by the ocean, the rate of absorption has been not accelerating very much in the last 20 years or so, maybe slightly. I used to say, 10 zeta joules per year, maybe it's 1 zeta joule, and now I'd say 11 instead of 10. But that's not enough to say that's really different. It may be just year to year variability. But I think what is accelerating is the temperature, somewhat at the sea surface, but substantially more so at the land surface. And most of the heat in the ocean, probably a higher proportion than 10 or 20 years ago, is staying in the top 700 meters. And probably more so at the top 100 meters, although I'm not really good on finding sources for the top 100. So the ocean
That's
heat
my
is
understanding as
going
well.
near the surf, staying more so than it was, it's staying near the surface, which tends to raise and perhaps accelerate the heating of the air at the land surface or air just above the sea surface. Although I would say I did a regression analysis on, what was I looking at? Cloud cover over the Atlantic and Pacific Ocean as a function of sea surface temperature. And it's more closely correlated with the passage of years than it is with the sea surface temperature. That surprised me, and I haven't done any follow-up to that. So it's a complicated system, and I understand a little bit of it, but there are many parts I
Gene,
don't.
I worked out where I got the 0.2 figure, and that is that this graph that you've got ends in 2023, and after that uptick at the end of 2023 in the line, it actually falls off a cliff. So the 0.2 is based on the last decade since 2017, and so that's why there's been a sudden increase in the darkening of the Earth over the last decade. So the rate basically doubled after 2013, and then doubled again after 2023. So that's where I got the 0.2 number. But Robert Chris wants to comment.
Well, it was just a general comment, really, that what we're talking about here is various incremental degrees of bad. And what is kind of sobering is that even if you take the base case of bad, which is where the IPCC scenarios are, it's still bad enough that we're in deep, deep trouble. So one of the things that I've been looking at recently are the CMIP 7 scenarios that have been developed for use in the modeling that will emerge eventually in AR7.
Oh, I didn't know they were out or they existed.
They're out. And they have 7 scenarios. And they have one of them is called the high emission scenario, which and they importantly they describe all these scenarios as plausible. They don't apply probabilities to any of them, but they regard them as being plausible in the real world. And
I like the idea of not putting probabilities on them.
Well, I think they don't do that because how can they know? I mean, it's stick your finger in the air because it's different degrees of policy failure, essentially. So,
Okay. Yeah.
and they won't know. I mean, nobody knows how the future is going to unfold, particularly, when you're looking at decadal periods. So it will be, I don't criticize them for not giving probabilities for these things. They just merely observe that the very high and the very low scenarios are probably less likely than the more central ones. So there's a kind of normal distribution, but it probably has very fat tails. Anyway, the point that I was going to make was that their worst case scenario, which this high emission scenario, which very briefly envisages carbon CO2 emissions climbing to 75 gigatons per annum by 2115, which is a lot less than the old SSP 8.5. And then after 2115, it then falls away to zero by 2275. So 160 years later, it
Now,
goes.
these are human CO2 emissions or all CO2 emissions?
That is fossil fuel and land use changes.
Okay, just the human ones, not the carbon sinks turning to sources.
Yeah, just human, exactly. Yeah, absolutely. Yeah. And now, and what's interesting about this is that this generates almost 4 degrees of warming by 2100, and it kind of climbs at it climbs at the rate of, I mean, an extraordinary rate, like 2 degrees every 50 years. So we don't need, in a sense, from a policy perspective, we really don't need to get too hung up about how bad it could be, because it's already bad enough. That's really the point I wanted to make. So we can dance around on all these details that we've been discussing this evening, but ultimately, from a policy perspective, they're largely irrelevant, because if we can't deal with even the base cases that are in front of us, we're screwed.
Yeah. What goes through my mind, Robert, is to point out to these policymakers and people like, is it Tim Lenton and others, Michael Mann, who say, no, we don't like the idea of SRM because one country would have to do it, and we don't know if we can trust any countries. But more to the point, we don't know what the side effects would be of all this nasty cooling. And it's incredible that Michael Mann would say that, but the UNEP have said that we don't know what all the nasty side effects would be of all this cooling, without any mention of the cooling influence already that's taken place, which is the source of all this disagreement about the ECS figure of 3 degrees or 4.5 or whatever it is. They seem to have completely missed it, and they've missed the fact that there's now this termination shock, which they so fear. You can't do it because there might be a termination shock. Well, it's already happening. You've missed. Where are you? You've been asleep for 20 years at least, 30 years.
And I think you're making absolutely valid points, Clive. But the point is not to kind of stand there and tear your hair out, those of us that have got hair, but to ask yourself, why is it that that's the case? And my conclusion, frankly, is that there are systemic reasons. The system that we have built, the global economy, the way that we have put our 21st century society together, actually obliges all of that to happen. And that, I think, is our central problem. We are not living in reasonable times. This is not a case of a bunch of smart guys sitting down and coming up with a rational solution to this and saying, oh, fine, yeah, we should do A, B, C, and that will sort it. Let's do it. That it isn't that kind of problem. It is absolutely the ultimate wicked problem. And and we don't have a mechanism. Society does not have a mechanism for dealing with problems like this. And that's why we're kind of flailing around and have been for the last several decades. And I ask myself, why should that change in the next 3 decades? And frankly, I don't see an answer, because it's the same system dynamic that is running the show. And the logical, sensible, rational views that you've just expressed, Clive, don't get a look in, because they don't fit the paradigm picture.
Well, of course, we do have a mechanism to address it, which is the model of the Albedo Accord, that is take a narrow technocratic approach involving a cooperation between business, science, and government, but which was abandoned by the Paris Accord as an approach to climate change.
Well, Robert, we have to agree to disagree on this. I mean, there are all sorts of theoretical solutions that one can dream up to this problem. I don't doubt that. And maybe the Albedo Accord is one of them. But the problem is that they don't fit the social paradigm of the age. And therefore the likelihood of them being realized is pretty close to zero.
Yeah, I mean, I'd say that, I mean, there was nothing in place for women to vote. There was nothing in place for, all that sort of racial
Or
apartheid
fixing the
stuff.
ozone layer.
Yeah, but
We
and
fixed
so
the ozone layer so we can fix the albedo layer.
Well,
yeah,
that is again a misunderstanding of the nature of the problem.
well,
A complete misunderstanding of the nature of the problem. The albedo, the ozone depleting substances is a completely different problem. It's a tame problem. It's not a wicked problem.
right.
And the approach to dealing with it was relatively straightforward. The thing you've got to remember here is, and actually I was talking to Dan Bodansky about this last week. Some of you may know of Dan. He's a kind of hotshot climate lawyer in the States. Anyway, he was saying, oh yeah, but Robert, he was disagreeing with me. He was saying, oh, you've got the Montreal Protocol and you've got the Marshall Plan as examples of global treaties that have kind of done good stuff. And I'm saying, yeah, you have. But the problem is that both of those, which interestingly both begin with the MP, they both fail to address one critical difference with regard to our current circumstance. And that is that with the Montreal Protocol and with the Marshall Plan, there were no losers. Everybody won. In the Marshall Plan, they just dished out loads of money. In the Montreal Protocol, the companies, it was primarily the companies that stood to lose by virtue of the treaty, were all handsomely compensated. So financially, it was a good deal for them. You can't do that with the climate because, particularly with cooling, the one thing that you can be almost certain of is that however you do it, there are going to be some losers because of just the way the climate system works. And not only are there going to be some losers but you're probably not going to know who the losers or who all of them are before you start the cooling. So people, countries around the world are going to say, hey, wait a minute. What happens if we're a loser? Who's going to protect us? Who's going to compensate us? How's that going to work? And you kind of get into this incredible mess of argument because nobody wants to be a loser. And the countries that might try this might start thinking, well, we're going to have to do this, and it's not like just doing a bit of cooling. We're going to have to do this permanently. It's not just the next decade; it's the next 100 years, 200 years. Are we taking that on for the world as a whole? And are we going to have to compensate any country that simply claims that this flood, this wildfire was caused by our cooling? Some of those things might happen anyway. I think one has to understand that the nature of the problem here is radically different from anything that humanity has confronted before. And we do not have analogues for this kind of problem.
I just don't accept that. I would say that the only wickedness in the geoengineering debate is the confusion around the non-use agreement. So, I don't accept that it's a wicked problem, and I don't accept that this claims of speculated loss are a wicked destroyer. But yeah, it's a fascinating debate. Thank you, Robert.
Yeah.
Just to pick up on that point, I'm not saying that the response that I'm describing is a rational one or a right one. I'm saying it's a human one. That's how people will react and how they'll behave, how they'll worry, how they'll fret, because that's what we do. We're not all rational. We're not all climate scientists that are in the weeds here that understand the details. But, the policymakers are not like that.
I think it has to be a superpower that just says, right, we're going to do it, and the rest of you just have to suck it up, whether you like it or not. Yeah. Greg Slater.
Yeah, thanks. Well, I had a particular question, but I wanted to just find Robert Chris just for a moment, which is that, just take the Strait of Hormuz. Nobody said, well, we're gonna attack Iran and we don't know for sure whether the Strait of Hormuz will close. And then all the nations say, well, look, you're going to harm us. And the U.S. said, fuck you. And they did it. And U.S. and Israel just said, fuck you, and did it. And that's the way it happens with power. I really don't think you can include power dynamics. Now you discuss the SAI argument and you say, well, all these countries are going to bitch and moan. And so there's only like 3 countries that matter in this discussion. All these other countries don't give a shit. Now, again, just like you, I'm not saying that's a good thing, but that's the way it is. Now, and I think your analysis does not really look at the way power acts when it feels like it wants to, and it doesn't give a shit about anything else. And I think I would be more appreciative of your analysis if you had a component of your analysis which addressed that very psychological issue. Additionally, because you obviously pay attention to the psychology of human nature, but that's the psychology of power that I question whether you are including. And let me get back to it. You can respond to that if you want, but let me get back to the point I was.
Do you want to respond to that, Robert?
Well, let me give my question in edgewise before that. Gene, we're coming back to Gene. Is it? I mean, there is this argument about whether you're double counting or whatever, but to whatever extent, I'm just trying to understand, to whatever extent the albedo evolution is going forward, regardless of your CO2 introduction, is it the case that, suppose we do everything we can, we stop CO2 production essentially, is it the case that the effects of albedo will cause the temperature? There'll be an increase in temperature, which will just keep dieseling. Will just keep going on due to the albedo alone. So we, instead of flattening out or whatever it's going to do when we would like it to do when we get off CO2 or we get off fossil, we get entirely off fossil. The albedo effects are just going to keep going and raising temperature, because it's the temperature that kill people, all that shit. So I'm just wanting, is those who have studied this, Gene et al., or is it the fact that even though there's a nonlinear connection between the CO2 introduction and the albedo increase, and that you stop the GHG introduction, and you then stop this albedo increase? That's sort of my general question. I don't know if it was coherent enough for anybody to respond.
Well, let me summarize what I heard toward the end. There's the greenhouse effect driving warming, and there's an albedo effect driving warming. And if you stop the greenhouse gases, what happens? And I think you were saying that the albedo effect goes on feeding on itself, which is the position I've taken, and I've no reason to stop taking that. I'm not sure that it would accelerate, but its deceleration, my gut feeling is it will decelerate, but it will be a very slow deceleration. And I'd certainly say that the future of Earth's temperature over the next century, or probably longer, albedo change will be a more important driver than the level of greenhouse gases.
Well, yeah, I see. I mean, and that's sort of what I was wondering. And the point I would make is that, I mean, I'm really interested, perhaps something like Robert Chris, that what's going on right now today is bad enough that I mean, there's catastrophes, that are playing out right now, and related to climate, but there's sort of this concept that's still embraced that, even if it's difficult, if we stop the greenhouse gases, we stop the heating, and if that's just bullshit, then we're really even more delusional than we thought. That even if we pull off this miracle of stopping fossil or greenhouse gas emissions, there's this other thing that keeps on going on its own, And that's important for the short term, not just a century or two out, because look at the increase term. Look at every tenth of a degree will go up. More crap is going on now, right now. We don't have to look out centuries for what these horrible things are be. And so the thing that I'm taking away from this, and perhaps wrongly, is that, we do this miracle one, we stop all greenhouse gas production, and we're still fucked. I mean, I'm sorry, I'm lapsing into profanity. I apologize.
Well, I would choose a couple of different words. I would not say the belief or position that if we stop putting greenhouse gas in the air, temperature stops rising. I would not call that bullshit. I would call that an incorrect assumption, which is now, sorry, with the data that we have learned, especially with respect to Earth's albedo change and a large change in cloud cover, especially over the oceans. I know 10 years ago I was saying this idea that we could put more carbon in the air in our carbon budget until we have a 50% chance of not exceeding 2 degrees Celsius. I say, well, the carbon budget, and this was 10 years ago, I estimated negative 325 billion tons of carbon, I think it was. And the carbon budget was positive before 1910, but not thereafter, is the way I looked at it at that point. But there was this movement to say temperatures rise pretty smoothly, well correlated with cumulative CO2 emissions. And I looked at that and I got a 95% R square. It's not as good as the 98.3 R square I got for temperatures over the same period as a function of methane, CO2, and aerosols. But I regard that as a happenstance correlation. There is reason that they should be correlated, but I think that it's happenstance. The correlation got to be that good of 95% R squared.
Right.
And it's just not the way the world worked, but
yeah, you're losing me somewhat, Gene. I mean, I have to watch it again. That isn't the one of the central things that nobody said is, I mean, the oceans take a long time to warm up. They've got such a huge. This is what Jim Hansen says that so you can stop emitting theoretically, but there's still so much. But there's warming in the pipeline, even for just ECS. There's plenty of warming in the pipeline. The oceans take time to warm up. Plus, we've got this stratification thing happening as well. And of course, as they warm up, you've got more water vapor, and there's all this feedback. I mean, the people who disagree with, I mean, what you're saying, Greg, I think we all agree with that, what you've said here, that you stop emitting, but it keeps on warming up quite a lot and quite a long way. The problem we have is that there are eminent scientists who disagree with that. I think it's Michael Mann, Susan Solomon, one or two others, produced a paper that said if you stop emitting, then, okay, there's a bit of overshoot, but then it comes down again and everything's fine. And but they seem to be in the minority. But they're the ones that the policymakers have latched onto and said, yes, we've just got to stop emissions. Am I right?
Yeah, I mean, I agree. There's more than one reason to worry after we pull this miracle off of stopping all GHGs. But the particular aspect of it that maybe I didn't quite understand and maybe is actually a problem is that the albedo effects just keep running. Now, if they are tied in with GHGs in a complicated system way, then maybe this is not a way to look at it. But I mean, there's also and this may be related again, the ocean effect. The ocean as a thermal sink or a thermal source after we stop. That may be the same thing. I don't even know. But to the extent that this is an additional issue of fantasy on our part of what happens when we achieve this miracle, that's worrisome, because we're trying to do this, pull this miracle off in the next few decades, not the next few 100 years. And whether that's just complete fantasy or not, that's what we're pinning our hopes on. But if the temperatures keeps on going the next year and onward, then I mean, yeah. So anyway, it's this additional component that I hadn't even been sort of aware of that Gina's talking about, to the extent that I've even grasped it at all. Yeah.
Yeah, I'm more confident in the continuing albedo feedback for ice and snow than I am for clouds, because I understand how the ice and snow feedback works. The clouds, there are plausible reasons, but I don't understand. Clouds are much more difficult to understand than melting ice and snow. And there's been a big change, and it correlates fairly well with temperature. But it correlates better with time than it does with sea surface temperature. And that doesn't lead me to say that cloud loss is necessarily going to continue. I think it will, but I'm by no means certain of that.
Yeah, well,
but I am certain that
more closely related to the loss of DMS emissions that produce.
that may well be.
Yeah, because that's more time related than temperature related.
I think there's a good reason to expect that cloud loss will continue, and that is because of the amount of heat going into the oceans, which is causing areas where the ocean used to be cool to now be much warmer, and as a result, evaporating the banks of clouds above them and causing those clouds to mix with the inversion layer above it. So these big banks of low cloud that sit off the west coast of most continents have been in very steady decline, was one of Celiudis's findings. And the main reason is because the ocean is warming up underneath them.
Yeah, it's possible that's the second most important thing that's going on after the loss of DMS. I've not kept up on DMS loss. I first heard we were losing it just not many weeks ago. And that's a very substantial contribution to aerosol forcing. I remember it's somewhere almost equivalent to almost 40 parts per billion of sulfates, the majority of which is from human industrial emissions, the occasional big volcano.
Yeah. I mean, it varies a lot, doesn't it?
Calculation was that 62% of the albedo loss is from cloud loss.
That seems reasonable. I would have guessed higher, but I wouldn't argue with 62%.
Yeah. Yep. We're running short of time. We've got 5 minutes left. Brian, please.
Yeah, I came in late, but I think there are several papers that describe the loss of subtropical and tropical algae across the Indo-Pacific, estimated at 30 to 40% loss over 60 years. And that would be consistent with the loss of 3 biogenic gases, dimethyl sulfide, isoprene, and mercaptan, especially at lower latitudes. And so that and similar events that we see off Panama with the failure of the Panama Pacific upwelling in January 2025 and a potential failure of the upwelling in January 2027 correlates very strongly with these loss of biogenic aerosols.
Mercaptan, I've never heard of that one.
Yeah, mercaptan is a gas that actually is the odorant in natural gas or fossil gas.
Is that also known
pipelines.
as hydrogen sulfide?
No, mercaptan is different, but it's easy to look
it's an
up
organic
on Wikipedia.
sulfide.
Organic.
Yeah, it's
An organic sulfide.
Organic sulfide.
Right.
Yeah.
And
very smelly.
Isoprene. Right. It's very smelly. And those are gases that are given off naturally by tropical seaweeds. And
how do you spell
probably
mercaptan?
microalgae. MERCAPTAN. Correct. And so these gases are significant, and we ignore the rest of our ecosystems at our peril. But I think there's this important feedback loop that is ignored by major parts of the climate community. And, they seem to understand that the climate disruption will affect ecosystems, but there seems to be some significant gaps in recognizing that ecosystems can have a profound effect on climate.
Yeah, that's right. Yeah, as I see it, there's what did Jim Hansen say? It's much easier. You understand. It's much easier to understand, not to understand something when your salary involves you, compels you to not understand something.
That's true. And Jim Lovelock told me 2 decades ago, personally, that he felt that DMS and other biogenic aerosols were largely responsible for the onset of the cryogenian period, which kept the Earth in a snowball Earth configuration for more than 11% of the last billion years.
Mm.
So having a lot of them would result in temperatures going down?
Yeah, he claimed there was some evidence that the discovery of DMS and other compounds in algae or bialgae about 1 billion years ago led to some improvements in production of both algae and biogenic gases. And those were so wildly successful that they were key contributors to the development of cryogenian Earth.
Now, that would make sense then. Intercept the incoming sunlight, cool the planet off.
It's very interesting.
That's how powerful it could potentially be. I think developing those theories further would be highly desirable.
Yeah. I thought it was the additional oxygen as wiping out the methane, because there would have been a lot of methane before oxygen came along. So,
I mean, the earliest oxygen events could have been almost 1 billion years earlier.
Yeah.
And so it's up and down several times.
It began over 2 billion years ago, but it took a while to get going, I think.
Agreed.
Yeah.
And CO2 levels were up and down as well.
Yeah.
But it probably is volcanic CO2 that got us out of the cryogenian period. But it's quite possible that algae, macroalgae and microalgae could have gotten us into it. We do have to recognize the sun was about 5% dimmer at that time, maybe 7% dimmer. But this could easily have been the straw that broke the camel's back.
Right. I don't think there was anything macro until the Cambrian period, was there?
Oh, no, we had macroalgae dating more than 1 billion years old, as evidenced by the fossil record.
Wow. Okay. That's real ancient stuff.
Some of the earliest multicellular organisms were algae.
Right.
Which leads to the conclusion that unless we address albedo, in particular cloud albedo, all the other things almost don't matter. If we address those, we can solve the problem. If we don't, we can't.
I do think it's compelling evidence that we need all 3 legs of the climate triad in order to sustain climate and civilization.
All 3 legs. Yeah. Yeah. And
good way to make friends and influence people.
Say that last thing again.
It's a good way to make friends and influence people is to recognize all 3 legs and not try to fight with big NGOs and the rest of the world that, in fact, emissions to zero is valuable and carbon removal would be pretty handy as well. But we must make room for climate repair or ignore it at our peril.
Yeah. Yeah. Okay. We've different ways of saying the same thing this evening, but they all mean the same thing. Yeah. Right. Thank you very much, everyone. That's it. We've had our time. This is a public upload. And that's it. See you in a couple of weeks. And we'll continue on emails. Yeah. Sure.
Thanks,
Bye, everybody.
Bye.